GAPS, Good Agricultural Practices for Enhancing Food Safety on Your Farm Produce. Water is an essential element in fruit and vegetable production, so ensuring the quality and safety of your water through periodic testing is a very important practice. Water is used in irrigation, pesticide applications, cooling, washing, processing, and ice making. Water quality also affects post-harvest produce quality by decreasing decay. But if water used to irrigate or wash produce becomes contaminated with harmful microorganisms, pathogens can spread throughout the crop. Of greatest concern are disease-causing pathogens, agricultural chemicals, and other contaminants. There are three main types of water used by fruit and vegetable growers: municipal water, well water, and surface water. Each has its own requirements for water testing frequency. The cost of water testing varies based on the types of tests required, but generic E. coli testing is always necessary. Of these three, municipal water is the least likely to have contamination issues. Municipal water authorities are required to periodically test water quality and report any problems to their customers. Water is treated as necessary to address water contamination on a regular basis. Municipal water quality reports can be requested from your local water authority. However, it is a good idea also to test the water at the pipe on your farm at least annually. This ensures that contaminants are not entering at any point along the pipes to your farm. Well water originates from shallow or deep wells that pull water from underground aquifers. If the well is properly constructed and maintained so that livestock and manure are excluded from the well recharge and pumping area, then the risk of contamination is usually low. Fertilizers and pesticides applied to the well field or the recharge area should also be applied properly to avoid contaminating groundwater. Well water should be tested once a year at the beginning of the growing season. Extra testing is warranted anytime an old well is brought back into service, any part of an existing well system is repaired, or following flooding. Surface water is vulnerable to many sources of contamination, such as wildlife feces, livestock manure and runoff from pasture or feeding areas, pesticide and fertilizer runoff, and naturally occurring soil-borne contaminants. Surface water such as a lake, stream, creek, an uncovered reservoir, cistern or well, an open canal, or a collection pond should all be tested monthly during the growing season. Now, let's take a look at how to submit a water sample. First, locate a water testing lab in your area, either a commercial lab or one providing services through a county or regional health department. Contact the lab and request as many sampling kits as you need. Each kit should contain a sterilized sampling bottle, a submittal form, sampling instructions, and a return mailing box for your sample. When collecting samples from a faucet or pipe, allow the water to run for several minutes before collecting the sample. Keep your fingers away from the mouth of the bottle and don't touch the lip of the bottle to the tip of the faucet. This can introduce bacteria into the sample. When collecting a sample from a surface water body, take several samples randomly throughout the lake or stream. Choose locations at least 6 feet from the bank and 1 to 2 feet below the water's surface. Invert the sample container until the desired sampling depth is reached to avoid collecting any algae or debris. Then allow the container to fill with water and cap it. Combine all the individual samples of water into a clean, sterilized container. Then transfer at least 100 milliliters into the test kit sample bottle for submission. Samples should be mailed back to the lab quickly, within about 30 hours of collection. Take samples early in the week so that they don't sit in the post office over the weekend. Test your water sample for fecal coliform bacteria. The EPA maximum contaminant level in potable water or drinking water for coliform bacteria is 0. If fecal coliform bacteria are present, it indicates that water may have been contaminated with manure and harmful pathogens. Remember that not all coliform bacteria are harmful, but if generic coliform bacteria are found in the sample, then E. coli 0157H7 could also be present. EPA limits for Cryptosporidium and enteric viruses are also 0. However, this does not mean that all water used in field production must meet drinking water standards. If contaminants are found in water to be used for field irrigation, then the method of irrigation should be considered. Overhead irrigation creates the greatest opportunity for produce contamination, and drip irrigation the least. Adjust your methods of water application based on the quality of your source water. When finalized, the FDA's Food Safety Modernization Act may provide additional guidelines on the required water quality for field irrigation, processing, and handling of fresh produce. Water used for processing needs to be higher quality than that used for field irrigation and should be monitored throughout the handling process to maintain quality. Water provided for drinking by workers and for hygiene must also be drinking water quality. Keep records of all water tests. If tests indicate the presence of contaminants, your methods of water treatment should also be documented and kept on file.